All right. We're gonna talk about off-axis rotation. Sometimes people get confused with the off-axis rotation, so we're gonna show you that. And hopefully we get to show method today. I know I'm trying to project. So I should be streaming right now. Hold on, let me try.
Yeah, Mr. Yeah, you're live.
Okay. But the problem, my iPad's not working. So I had to restart my iPad again. Yo, Tanner. Hopefully my iPad works. Okay, it's working. All right, so off-axis rotation. So with the off-axis rotation, I'm going to use the same equation, but you are going to get different equation. With the off-axis rotation, you just make sure you follow certain things. I set up something last year, but it's not like, not probably like probably not the best way to teach math. Is to just kind of teach kids how to think about the shortest path. So for me, like if you have certain thing, I will probably always draw the axis of rotation first. Draw the axis rotation. And second, I will draw a line or lines, right, from axis rotation to the bound or boundaries. It could be plural. So either one bound or two bound, right? So we talk about if it's a one line, then it's more likely to be a disk. If it's two line, it's more likely to be a washer. Third, usually you decide the dx or dy because it depends on the slice. If the vertical slice, so I would say vertical slice is gonna be dx. If horizontal slice is gonna be dy. Then I would decide a bunch of different things. So let me turn off this. Okay, so one thing I will probably make sure is make sure the correct boundaries. Make sure correct correct boundaries. So what I mean by I could be using y bound rather than x bound. And right equation, of course. So right equation, correct equation. And dx and dy. So correct boundaries. Now, make sure that if you let's just say I'm gonna give you a question. I start right here. So let's just say if I want to rotate around this line. So this what I'm gonna do axis rotation. I'm gonna just show you example. Let's draw axis rotations here. By a bit. So it's this disc a washer.
No, it would be this. Oh, this. I thought I only heard washer.
So this is not the x-axis or y-axis. Okay. Jing, is this gonna be a disc or washer? Disc? Okay, what kind of shape will this look like? Like, can you describe this shape? Yeah, what kind of 3D shape like is like the best description that you can come up with? It's not half a football, no. It's not half a football. It has nothing to do with football.
Oh, oh.
Oh, I see how it is.
So what you're gonna do is you're gonna draw from the axis rotation. If you have a problem, you draw from the axis rotation. It has to start from the axis rotation to the boundary, right? So you're gonna draw it to this way, and that is your slice. Is this dx or dy? This is gonna be dy, right? Is that okay? This is dy. Is that okay? So we had to make sure the function's in terms of y rather than in terms of x. So remember, we have the functions y equal to square root x. We had to solve for y, so that's going to be x equal to y squared. But this is where people did wrong. What will be an equation for this one?
You mean like the integral?
Yeah, I'm not asking you yet because you have quick at a dimension. So I need to ask somebody who's not good at dimension and can tell me what will be the integral here. The equation or the bound or whatever. 4 minus a function.
Like the square root is also.
Okay, that's good. The reason being is the y square, right? Sorry. The y square. A lot of people think about it's probably just integration of y square square between 0 to 2 dy. But it's actually not because this is the y square. Does that make sense? This is the length of y square. But I'm trying to get a red line. So therefore, in terms of this, it's going to be 0 to 2 dy. So I know I have to be everything in y. But I cannot just use y squared. Y squared is based on this rotations. Is based on this rotations here. But that's wrong because we want to base on this rotation. So we want this distance. And this distance is given by 4 minus y squared. So by the red line is actually the blue line. Sorry, the blue line. Well, the blue line from here to here minus the black line to get a red line. So that's what you had to be careful. This one is going to be off rotation. So it's actually 4 minus the blue. Oh, blue is 4, sorry. Minus y squared and then square. Does that make sense? And also pi, thank you. Pi r squared. Is that okay? Bishop?
Yeah.
Jing? Good? Okay. Melissa? Catherine? Good? Okay, then I'm gonna give you a new one, okay? With the same graph, I'm gonna give you a harder one. Is this, but it's rotating at it's rotating here. Okay, each individual is gonna work on their own for like 2 minutes, set it up correctly. Set up correctly. On your own. That's what everybody got confused last year when it's off-axis rotation. First one, I'm gonna ask certain people. I'm gonna ask Lyndon. I don't know if you're good at volumes last year. Besides,
should now be back from A1.
it's really hard to think about this shape. Like, can you describe this shape?
I mean, I can like visualize it, but I can't. I don't know how I would like if I could relate it to something.
It's like the but like
How the equation?
Yeah.
Like I know the.
It's like it's like
What is
the
like what value? Like what?
portion of
What?
like if you have
What
to
value?
have a piece, and then you just
It'd be like this whole thing. Is this right? It is equation.
It's the same as
Jin, you finished?
I mean, I haven't evaluated, but I have the.
So Ethan, can you check Jing is on the right track or no?
Uh,
I thought it was a 6. What is the Y value of the frequency rotation?
no, that part is correct. You just need another part for it.
I don't know what you're trying to ask. It's not because I didn't want to answer your question. What?
Oh,
Dude, count it.
oh.
Always shaded.
That's fine. Alright. Like, is there a timeline in the season?
So,
I did 4 minus 1.
Lyndon, what you get?
At first I was trying to do washer, but I'm trying to.
It is washer. It is washer.
Oh yeah. And then I got parentheses C4 minus X equals something squared. It's like, I don't get that.
No.
Good shift?
I end up with integral for pi from 0 to 2 of 4 squared minus
0 to 2? No.
4, sorry.
0 to 4?
4 minus root x squared.
4 minus what?
4 squared minus 4 minus root x squared. That's the quantity of 4 minus.
Okay, so let's see that's right or wrong. So what I'm gonna do is I'm gonna start from an axis rotation. Remember how I draw my boundaries? So my boundaries start from this part. It's not from any other part. It's not from the x-axis, but from the axis rotation. Draw towards the boundary. Now there is a outer bound, and there is a inner bound. Right? There is an outer bound and inner bound. So now you know automatically when you draw this, you know this is dx. Does that make sense? This is a dx because it's a vertical slice. It's rotating. Now, so if we just based on the purple slice, if you just rotate it, it's gonna give you a whole cylinder. Now, is this cylinder is carved out the hole in the middle. It's kind of like yesterday that when we watching the video, they trying to carve out the things in the middle. So it's actually it's gonna be washer. So not only that, so start by asking is okay, this is a dx, and this has to be a washer because there is a two things that you have to worry about. Okay. So once you washer, then you say, okay, well, what is the big R of x, and what is a big R of a small r of x? So in this case, the big R of x is the purple line because it's all the way to the end. So that has to be constant throughout the whole way. Either here or here, it's always the same value. So that's equal to 4. Does that make sense? Are you following me? Everybody follow me? Vanessa, it's okay? Now, what would be a small r of x? It's equal to, well, here's the thing. This is the equation. So y equal to square root x. So it's actually the purple minus the black to get the red. Does that make sense?
Yeah.
The purple is 4 minus black. So 4 minus root x. And then that's going to be between 0 to 4. And that's going to be 4 squared minus 4 minus root x squared dx pi. And that's how I get my result. Jing, did you get that? Yes? At first try or the second try?
I thought we were taking the volume of the part above the x.
Okay.
We didn't realize it was water.
You guys got it? I'll try again. Same rotation. So now I'm gonna go from here and I'm rotating around this line. Rotation here. Still the same function. If you understand same function, different rotation, you're good. This year was the hardest thing. This unit was one of the hardest thing that you did last year. Everybody failed the test. You got 100?
No.
I don't remember.
Oh no, I think I had it. You probably didn't know.
Actually, I don't remember when this would have been, so this might have been during when I just wasn't really caring about calculus.
Decide dx or dy. Decide the boundaries. Make sure the boundary is correct. If the washer, there's a big R of x or ry in this case. What is small r of y? If a disk, then it's big R of x. In this case, there's only two type of disk can possibly form, which is the one that. I'm gonna ask. What I should ask? I'm gonna ask Isabel on this one. Isabel, you think you can get this? Okay. Today's homework is gonna be 4 different FRQ from all years, and then also the different rotation of this.
Oh, okay, yeah. Wow. It's not okay. That's not justification for it, Katie. No. You'll have to file a complaint.
No, I do it.
You do it every day.
Good chef, you doing okay? You got an answer? Isabel, you done? Not yet? Okay.
Because 6 is good. I put 4. And I was like, somewhere.
Wesley, you doing okay?
Yeah.
Okay. Isabel, you want to tell me your answer?
I got pi times the interval 0 to 2 of 2 squared minus y squared plus 2.
2 square?
2 minus y squared plus
2 minus y square
2.
plus 2 like this? dy? I think there's something wrong here. Anybody else? Ria?
Okay, I didn't do 2 though. I got pi times 0 to 2, 6 squared minus, in parentheses, 6 minus y squared.
6 minus y square. I think that's right. That's right, right? That's close, right? Okay, so let's draw it. Let's draw it. I think the hard part, like you guys need to try to draw this. So I'm gonna draw this from here to here. This is my big R. Does that make sense?
Yeah.
So that is gonna be a dy. And this is my small, so therefore is washer. So I decide this is going to be dy, and that's gonna be washer, and 0 to 2, and pi, and then what's a big R of y? The big R of y in this case is from here to all the way here. It's always the same. So it's gonna be 6. Does that make sense? Now for the purple line, I would like to draw a 2 line. I'm drawing this and that. So R of y is gonna be 2 plus y squared, right? So y equal to x, square root x, so x equal to y squared. So that's gonna be 6 squared minus 2 plus y squared squared dy. Did everybody get that? Did it? Yeah.
You add 2 because
The-
the axis rotation is -2.
Yeah, so the way kind of think about it, I draw this in 2 segments, right? So one first segment's from here, this is always 2. But this is given by the functions. Anything start from the y-axis or x-axis is the functions. Rather they are in terms of x, in terms of y. So they are if you calculate start from the axis, that's gonna be the function. So that's why sometimes when I do like axis rotation this way, that's gonna throw a lot of people off because that's gonna be that's what's gonna next to do. Does everybody understand this? Lax me? You got it? The first try or the second try? Okay. So we need you to get a first try because that's okay. That's what we're here for. So same thing, but my alpha axis rotation is gonna be at 7 now. It's gonna be at 7 right now, and hopefully everybody get this one right. You just had it set up. You don't need to get an answer, yeah. Because on the test, the first question, I'm gonna ask you like a lot of different setup. What? What'd you say? This one, it's gonna trick a lot of you guys. But if you guys know what you're doing, then you're okay. Draw the line properly. Always think about from x-axis or y-axis is the function. It's not represents the big R small r, not all the time. Sometimes it does, but not all the time. We're probably not gonna. What? How much time I have? We're probably not gonna get to shell today. Monday shell and cross section, and Tuesday is the arc length, which is that's easy. Yeah. So. How'd you get 11?
No, you're rotating around 7. Why wouldn't you just if you're rotating at 7 and the world gets stuck, you did 3 different ones, bro.
Jing, you finished? You got same thing as Ethan? All right, so the way I did this is just draw it out. You will see something. So if I draw it out from here, I know my slices is gonna be dy, and it's also a washer because I'm gonna reach two boundary here. And I know that this is dy, and I know that it's gonna be from 0 to 2. I know that's gonna be washer. I know that if it's a washer, it has a big R of y and small r of y. What is a big R of y in this case? Catherine, what is it? What's a big R of y in this case? What is it? It's not 7, but that's a good try. 7 is from here to all the way here. Seven minus y squared. Good job. 7 minus y squared, because y squared is from here to here, right? That is a function. This, remember, from the axis to the thing is a function. This is a y squared. So 7 is pretty much the whole length from here to here, the brown minus the black to get red. Is that okay? How about small r of y? Corbin?
The small r would be
3. Good job. So it'll be integration pi. Don't forget pi. Don't ever forget pi. 0 to 2. 7 minus y squared minus 3 squared dy. Kashif, you understand this? Raphael? Catherine, you got understand?
Mystery explain real quick why it's 7 minus y squared.
Because
I was thinking it would be I was thinking like y squared minus 3 because it's like 3 behind the axis of rotation.
yeah, but the way you calculate is you're looking for this, right? So the best way to look at, because this is constantly changing too. This can be here, this can be here, this can be here. So basically is this, take away the black to get the red part.
Got it.
Because this is always 7.
Yeah.
This is one that's changing.
So can I take where the axis is and then do I just add subtract the function? Like, because the axis is 7, you're gonna do 7, and then because the function is to the left, vertical line, you're gonna do subtract y squared.
Yeah.
And if it was to the right, I would do.
No, I won't even like think about to the left or right. It's kind of confusing for me. For me, I just look at I'm only interested in this length
Yeah.
at all time.
Okay.
The only way to get that is this part minus this one to get this.
Gotcha. Okay.
If it's on here, then it's this part plus the functions, right?
Yeah.
So it's different. So
Okay.
each
Thank
time it's kind of different. So that's why each time you gotta figure your own thing. Then shell method, it's gonna be one more